to Chem Vid. Today we are going to be talking about stoichiometry. So as a review, we know how to go from moles to mass and mass to moles, and how to go from moles to how many molecules, particles, whatever, and back and forth. Stoichiometry is the way that we predict chemical reactions by going from mass of a reactant to mass of a product that should be produced. Okay? So we're going to take mass of something, go to moles, and then be able to go to moles of another substance. So that's what stoichiometry is. So let's review 1 through 3. In number 1, it asks me to go from moles of SO2 to grams of SO2. So moles go, I first write out 4 moles of SO2. Moles go on bottom, grams go on top. I get this lovely number from the periodic table, multiply across, and there are 256 grams of SO2 in 4 moles. In 2, it says how many molecules are there. So I start off with the 4 moles of SO2, moles to molecules, moles cancel out, and I'm left with molecules. And that's how I get my molecules. And then for number 3, they want to know how many atoms, so I have one more step. Molecules cancel out with molecules. In 1 molecule of SO2, I have 3 atoms, so I would multiply those 3 numbers together, and I would get the number of atoms. So the big thing that we worked on with these conversions was the fact that our units always have to cancel out, and we use the periodic table when we're trying to get from grams to moles, and we use Avogadro's number when we're getting from molecules to moles, and that a molecule is different than an atom, and so you need to watch your units to make sure your answer makes sense. Alright, so let's start off with a mole-to-mole conversion. Now, the most important thing about a mole-to-mole conversion is you must have a balanced chemical equation. Alright? So if you would, go ahead and highlight, star, circle, whatever you need to do. But the first thing before you can ever do anything about changing any type of reaction or predicting a reaction is you have to have a balanced chemical equation. Alright? So, if I look at a balanced chemical equation, it is a recipe for how to create something. But instead of using eggs and flour make cake, I'm using chemicals. Certain chemicals, when mixed together, will make other chemicals. Alright? So if I look at this equation, it says 1 sulfur plus 1 oxygen molecule will make 1 sulfur dioxide molecule. Okay? And that 1, the coefficients that are in front, that refers to what we call the molar ratio. So the molar ratio tells me how many moles of a substance I need in order to make moles of another substance. So if I look, it says how many moles of SO2 can be formed by burning 4 moles of sulfur. Well, if I look at my ratio, for every 1 sulfur burned, I make 1 SO2 molecule. Okay? So my ratio is a 1-to-1. I'm going to put moles of sulfur here on the bottom so that my moles of sulfur and my moles of sulfur cancel out. And then I'm going to take my moles of SO2 up here at the top because that's what I want. And it is a 1-to-1 ratio. And now I know that I need 4 moles of sulfur to make 4 moles of SO2. Pretty straightforward, pretty easy, but this way of setting it up with dimensional analysis will make sure you always get it right. Okay? Now, here's something I also want you to star, remember, put a note by. The only way you can change from one reactant or product to another is through moles. Moles is the only thing that will relate the different reactants and products in my balanced chemical equation. So I can never, ever, ever go straight always use the molar ratio whenever you want to transfer between one substance to another substance. Okay?
Alright, so now we're going to go from mass to mass. Moles is how our balanced chemical equations are set up and how we do things theoretically. But in the lab, we have to be able to measure out masses. We measure grams, not moles. So I need to be able to go from grams of a reactant to grams of a product. Okay, so again, whenever we're trying to figure out balanced chemical equations, how much of something is going to make something else, anything like that, we always have to have a balanced chemical equation. Very important, always needs to be done. So, given the following reaction, sulfur plus oxygen goes to sulfur dioxide, how many grams of sulfur dioxide would be formed by burning 8 grams of sulfur? I start off with what I have. I started off with 8 grams of sulfur. Now I need to get this into moles first because I have a molar ratio for the coefficients. So I'm going to put moles of sulfur and grams of sulfur so I don't forget which one they are. Then I can go from moles of sulfur to moles of sulfur dioxide. Remember, I have to use moles. I can't do it with grams. Then I go from moles of sulfur dioxide to grams of sulfur dioxide. Alright, so sulfur weighs a certain amount and it's always equal to 1 mole. Moles to moles, this guy I always get from the balanced chemical equation. Alright? So whenever I'm trying to get moles to moles, I always look at the balanced chemical equation. Whenever I want grams to 1 mole, I always look at the periodic table. Okay? Periodic table. So, sulfur dioxide was 64 grams, and sulfur is about 32 grams. I look at my chemical equation and I see that there is a 1 in front of the sulfur. It's implied, not actually written. And then there is a 1 in front of the sulfur dioxide. Implied, not written. So now I know that 8 grams divided by 32 grams will give me the moles of sulfur. It's a 1-to-1 ratio. And then I can turn it back into grams of sulfur dioxide by using the gram to mole conversion. And I get an answer of 16 grams of sulfur dioxide can be produced if I use 8 grams of sulfur in my reaction. Okay? So the things that I want you to write down on your notes, make sure you write out this entire dimensional analysis. I want you to write out that you use your periodic tables to go from grams to moles. You use your balanced chemical equation when you're going from moles to moles, and periodic table for grams to moles. Alright, so because we do this in order to predict chemical reactions, it's important that we have this stoichiometry going from grams to moles to grams down. So here's the little rhyme that we use whenever we're asked to go from mass of one substance to mass of another substance. Grams to moles, moles to moles, moles to grams. Okay? So I always go from grams of A, whatever my reactant or whatever it is, grams of A to moles of A to moles of B to grams of B. So if you remember this pattern and set up the dimensional analysis according to this pattern always, it'll work. All you have to do is remember the pattern. So if this is a struggle for you at first, remember the pattern, and then as you remember the pattern and as you do it more, you'll come to understand why you do it, and it'll get a little bit easier to predict things in the future. Alright? Okay, so now we're going to try something different. How many grams of oxygen would be needed to produce 3.20 grams of SO2? So in this question, now they're asking us not how much SO2 can be made, but they're asking us how many reactants or how much reactant we need in order to make a certain amount of product. So instead of asking us how many cakes we can make, it's asking us how many eggs do I need in order to make a certain amount of cakes. So first I start off with the amount of cake I want to make. In this case, it's 3.2 grams of sulfur dioxide. And then, since I'm trying to get to another compound, I follow that same rhyme. Grams to moles, moles to moles, moles to grams. Alright, so here I have it. My grams of sulfur dioxide on bottom, then I go to moles of sulfur dioxide. I use my molar ratio from the balanced chemical equation to get my new amount of oxygen. And then I do my oxygen, moles of oxygen, to grams of oxygen. I use my periodic table to get from grams to moles. I use my balanced chemical equation to get from moles to moles. And I use my periodic table to get from moles to grams. Alright. When I multiply by 32, divide by 64, I get 1.6 grams of oxygen is needed in order to make 3.2 grams of sulfur dioxide. So this ratio and this way of being able to look at a chemical reaction allows you to predict how much product is going to be made or how much reactant you need in order to make a certain amount of product. It goes both ways, but the way that we do it is the same. Grams to moles, moles to moles, moles to grams. Now if you would, I would like you to practice this. Number 7. Please do number 7. Look at your notes, look at what we've done before, and see if you can do number 7, A and B. Pause the video. Okay, so how many moles of water are produced when 4 moles of methane combust? I start off with my moles, and then I go from moles of methane to moles of water. Since the question only asked me for moles of water, I don't have to do anything with grams. So I multiply by 2, and I get 0.8 moles of water. In B, they ask me for grams, and they give me my reactant in grams. So therefore, I need to do the whole stoichiometric process. So I start off with 8 grams of methane, and then I go from grams to moles, moles to moles, moles to grams. Grams to moles come from the periodic table, moles to moles comes from my balanced chemical equation, and moles to grams comes from the periodic table, which gives me 32 grams of oxygen is required to react completely with CH4 so that there are no reactants left over. That's what the word completely means. It means there are no reactants left over. Alright, last practice for tonight. Try number 8. Balance the chemical equation and answer A and B. Pause the video, try it out, and then see if you've got it right. Okay, so 68 grams of ammonia, and I want to know how much hydrogen I am going to need. So I balance my chemical equation, and then I take 68 grams of ammonia, grams to moles, using the periodic table, moles to moles, using my molar ratio from the balanced chemical equation, moles to grams, and I get 17 grams of hydrogen is required to make 68 grams of ammonia. For B, it asks how many grams of nitrogen do I need to react completely with 10 grams of hydrogen. So I start with what I know, 10 grams of hydrogen, grams to moles, moles to moles, moles to grams, and I get 46.7 grams of nitrogen. Stoichiometry is just this pattern, grams to moles, moles to moles, moles to grams. So if you know how to get each conversion, the periodic table and the balanced chemical equation, and you know this pattern, you can find out how to produce as much as you want, or how much reactant you need, or anything like that. That's it for today. In class, we'll go over percent yield. Thanks for tuning in.